Hello everybody, it's Mr. Moore. So today we're going to be talking about simple probability. Okay, we're going to do a very quick overview of simple probability. It's just a quick review for you. Now, as you remember, previously learned skills that are going to assist you with learning in this particular unit would be your use of rational numbers, okay, whether it be addition, subtraction, multiplication, or division. Specifically dividing fractions and decimals. Comparing and ordering rational numbers, comparing fractions and decimals would be a specific skill that we need to be aware of. Solving proportions, making expressions equal to each other, which we've already done, and then converting fractions between decimals and percents. Remember to use the triangle power, where I can get from a fraction to a decimal to a percentage, and so on and so forth, backwards and forwards. Okay? So now, also, if we take a look at this next page, now probability is going to be defined as the chance that something will happen, how likely it is that something or an event will occur. Sometimes we can measure a probability with a number like 10%, or we can use words such as impossible, unlikely, possible, even chance, and likely and certain. So if we took a look here on the far left, we see that a 0% or zero chance is going to be equated to something that is impossible. So for instance, walking out in the morning and seeing a blue sky with unicorns fluttering by, okay, that is going to be an impossibility. Now, having a blue sky, that is wholly possible, but having a blue sky with unicorns passing by, 0% chance or zero possibility. Now, where you would have unlikely, typically, we're going to think about that percentage as about a 25% chance unlikely. So say, for instance, if you were to have 4 pieces of paper, one that is yellow, one that is blue, one that is purple, one that is green. Okay, if I were to crumple those up, stick them in a paper bag, what is the probability that I would pick a green out of that bag? Is going to be a 1 in 4 chance, or 25%, but it is still unlikely that I would pick a green piece of paper. An even chance, using that same example, what if I again had those sheets of paper, and if I said, what is the probability of me picking a green or a blue? I believe that I said blue. So again, if we had a blue, purple, yellow, and green, if I wanted to pick a blue or green piece of paper out of that bag, there's going to be a 2 out of 4 chance or a 50% chance. So that's going to be an even chance that I'll get it or not. Likely. Okay, likely. So if we look at the example that we have here, what is the probability of those 5 balls that we see that I would pick a blue ball? That's 4 out of 5 chances. Okay, so again, that is likely. That's going to be associated with about a 75% chance. Now, a certainty is something that will occur. If today is, say, Saturday, what is the probability that tomorrow would be Sunday? Okay, there is a 100% probability that there would be Sunday on the following day if today was Saturday. What is the probability that tomorrow would be Monday if it's Saturday? That's a 0% chance. But again, if it's Saturday, the following day being Sunday, that would be a 100% likelihood. Okay? So the example is, again, it is unlikely to rain tomorrow as a number. Probability is from 0 to 1 as a number. When you're talking about percentage, anywhere from 0 to 100%. If that is a fraction, it can go from a 0 all the way to a 1 out of 1 possibility if it's a fraction or ratio. All right, so on to the next one. So sample space is going to be the set of all possible outcomes of a probability experiment. So the example shows choosing a card from a deck. There are 52 cards in a deck. That's not including your jokers. So the sample space, the set of all possible outcomes, is going to be 52 possible cards. Okay. Now your simple event again is going to be an event which is a single element of the sample space. So before we move on to our examples, the probability of a simple event, remember, is going to be the number of favorable outcomes over the number of possible outcomes. So if I had a regular 6-sided number cube, If I were to roll it, what is the probability of rolling a 4? Remember, there are 6 different possibilities. I could roll a 1, I could roll a 2, 3, 4, 5, or 6. There are 6 possibilities. So the number of possible outcomes, as we see here on the right, is going to be 6 possible outcomes. That yellow highlighted cube there where we would roll a 4, there is a 1 out of 6 probability that you would get that 4. So again, the number of favorable outcomes, that's what I want, is the number 4. So there's only one possibility of getting a 4. If I were to roll that number cube, it's not going to levitate on one of its corners where I don't have anything. Gravity is always going to force it to land on one side or the other. Okay? So we're going to move on now to our practice problems. So using this first example, on each of 4 slips of paper, you wrote the word salad, sandwich, soup, or pasta. Every day, you choose 1 slip of paper from a jar to help you decide what you would eat for lunch. You always put the chosen slip back into the jar. Okay, so you are replacing that slip of paper every time. What is the probability of choosing a soup on any given day if you always have 4 possibilities? So again, the number of possible outcomes is going to be, and I'll turn my writer on. Okay, the number of possible outcomes is always going to be how many? So again, I have salad, sandwich, soup, and pasta. There's always going to be 4 possible outcomes here. 4 possible outcomes. That is the number of outcomes that you could get. It doesn't say that, say, a popsicle is one of those options. There are only 4 options, and they're always in that bag. So if I wanted to figure out what the probability of getting or choosing soup, again, that's where each sheet of paper is going to be the same size, so there is an equal likelihood that you would get any of those sheets of paper. So how many opportunities would I have to pick soup? I only have 1 opportunity to pick soup. So again, 1 out of 4. That's 1 favorable outcome out of a total of 4 possible outcomes. Now let's think about that. As I said at the beginning, you have to be able to convert between percentages and between ratios or fractions. So I know that the benchmark fraction 1/4 is going to be equal to what percentage? It's going to be equal to 25%. So here is my answer. All right, let's move on. I'm going to clear our screen. Okay, clear my annotations. So next, we have the next one. It says, look at the chart showing the results of a baseball player at bat. Okay, so this baseball player, she is at bat, it looks to be 6 different times. Okay, what is the probability that that person will get a hit based on their results? Okay, so let's figure out, first of all, how many possible outcomes were there? Think about it. You're absolutely correct. There were 6. That's 1, 2, 3, 4, 5, 6 different possibilities. So 6 possible outcomes. Okay. Now, of those 6 possible outcomes, how many times did that person actually get a hit? So I'm going to change this to green. So we got 1, 2 hits. Okay. I'm going to change that again. We'll change it to pink. So 1, 2, 3, 4. 4 outs. That's a T. Okay. So we're looking for the probability that we get a hit. So what are the favorable outcomes when it comes to the number of hits? Okay. You're absolutely correct. It's going to be 2 out of 6. Okay. So let's look at our answer choices. I don't see 2 out of 6. Am I wrong? Oh, you know what I forgot to do? I forgot to simplify my probability. So we know that 2/6 can simplify to 1/3. So I have 1/3 as my answer. Okay? Now, On to the last example. All right, so let's think about that scale one more time that we were looking at earlier. Let's think about the scale. So this is a continuum where I have a 0% chance, I have a 100% chance. Now there is a qualitative and a quantitative way to describe probability. Quantitative talks about numbers, hence the root quanti, Q-U-A-N-T-I, that deals with numbers, and qualitative, that deals with describing it with words. So we have 50, I have 25, and I have 75. Okay? Now, 0, remember, was impossible. That's an I. 25 was going to be unlikely. 50 was going to be equal chance. 75% was going to be likely. Okay? And then 100% was going to be certain. Okay? Hopefully that translates. And these are all percentages, you guys. Okay? So 0%, impossible, 25%, unlikely, 50%. Equal chance, 75% likely, and a 100% certain. Okay, let's look at our question. The weather forecaster says that there's an 80% chance of rain today. Which statement best describes the likelihood that it will rain today? Is it likely that it will rain today? Is it neither likely nor unlikely that it will rain today? It is unlikely that it will rain today, or it will not rain today. So if we think about this as a number line, remember we have done lots of practice over the years with number lines. Where would 80% fall on this number line? I'm going to say that probably 80%, and I'll change the color here. 80% falls somewhere in there, okay? So it's between, at this point, likely and certain. Okay, so how would I describe what I just wrote? Okay, so how would I describe that? Actually, let's go back. Okay, so I want to go ahead and fill this in. So it is likely that it will rain. It is neither likely nor unlikely. It is unlikely. So where does that fall? You're absolutely right. It falls here as likely because it is between 75, that is likely, and certain. It is not certain because it's not 100%, okay? But it is closer to 75. The number 80 is closer to 75 than it is 100. But again, it has to be 100% to actually qualify as a certainty. All right, you guys, that is the end of our quick wrap up for simple probability. Okay, hopefully this was helpful for you. If you have any additional questions, you are more than likely, or more than welcome, I should say, to ask me in class or during a tutorial session. Thank you, and I'll see you guys soon.